You're designing a virtual network in Azure and you have three overlapping tools that all touch traffic: network security groups, application security groups, and route tables. Pick the wrong combination and you'll either leave a subnet wide open or spend an afternoon debugging why a perfectly valid request is being dropped. In the next few minutes, I'll show you what each one actually controls, where they overlap, and a concrete framework for deciding which to reach for. The short version: network security groups decide whether traffic is allowed, application security groups decide who the rules apply to, and route tables decide where traffic goes. Let's make that precise. A network security group, NSG, is a stateful firewall made of priority ordered rules. Each rule has a priority from 100 to 4096, a direction, a source and destination, a port range, a protocol, and allow or deny. Azure evaluates inbound and outbound rules separately, lowest priority number first, and stops at the first match. Because it's stateful, if you allow an inbound flow, the response is allowed automatically. There are default rules you can't delete, including one that permits all traffic inside the virtual network and one that denies everything else inbound. You attach an NSG to a subnet, to a network interface, or both. When both apply, inbound traffic must pass the subnet rules, then the NIC rules, and outbound goes the other way. Rule of thumb: attach at the subnet for broad policy and only use NIC level for genuine exceptions. Application security groups, ASGs, solve a maintenance problem. Without them, you write rules against IP addresses and ranges, which breaks the moment you scale out or readdress. An ASG is a named label you attach to a virtual machine's network interface. Then in your NSG rules, you reference the ASG as a source or destination instead of an IP. So you create a web ASG and an app ASG and write a rule that says, allow port 443 from web to app. As you add more web servers, you just tag them, and the rules apply automatically with no change to the NSG. ASGs don't allow or deny anything themselves. They only describe membership. They live inside NSG rules, so they're a refinement of NSGs, not a separate control. Route tables are a different concern entirely. NSGs and AS decide whether a packet is allowed. Route tables decide where it goes. Azure already has system routes that handle traffic inside the virtual network to peered networks and to the internet. A user-defined route, UDR, overrides those. The classic case is forcing traffic through a network virtual appliance or Azure Firewall. You set a route for 0.0.0.0/0 with next hop type virtual appliance pointing at the firewall's private IP. Now all outbound internet traffic is inspected. You can also use the next hop type none to black hole a range or force on-premises traffic through a gateway. Route tables attach to subnets only, never to ANIC, and the most specific prefix wins. In practice, you layer all three. Think of a packet leaving a web virtual machine. First, the route table decides the path. The UDR sends it to Azure Firewall instead of straight out. Then at each subnet boundary, the NSG evaluates whether the flow is allowed, and your rules reference ASGs so the policy stays readable. The key insight is the order of concerns. Routing first determines the path, then filtering decides or block at each hop. They don't conflict because they answer different questions. A common mistake is adding a UDR to force traffic through a firewall, then forgetting the NSG still has to permit the return path, or assuming the firewall replaces your NSG's defense in depth means keeping both. A few traps worth calling out. NSG rules are stateful, so don't waste a return rule for an allowed flow. The default deny inbound rule has priority 65,500, so any allow rule needs a lower number. When you both have subnet and NIC NSGs, troubleshoot with NSG flow logs or the Network Watcher IP flow verify tool, because silent drops are usually the layered rule you forgot. With route tables, watch for asymmetric routing when a UDR sends traffic one way, but the response takes a different path, which firewalls will drop. And remember, ASGs and the NSG that references them must be in the same region. When in doubt, check the current Azure docs, since limits and default rules do change. So here's the framework. Ask what question you're answering. If it's should this traffic be allowed, that's a network security group attached at the subnet by default. If it's how do I keep those allow rules maintainable as I scale, reach for application security groups and write rules against roles instead of addresses. If it's where should this traffic flow, especially routing through a firewall or appliance or back on premises, that's a route table with user-defined routes. Most production designs use all three together, not one instead of another. Start with subnet NSGs and ASGs for filtering, then add UDRs only when you need to steer traffic through inspection. To recap, network security groups filter traffic with stateful, priority-ordered allow and deny rules. Application security groups make those rules readable by targeting roles instead of IP addresses. Route tables with user-defined routes control the path, most often to force traffic through a firewall. They answer three different questions, and you'll usually layer all three. Your concrete next step, open one of your existing virtual networks today, look at a subnet, and check whether its NSG rules reference raw CID or blocks. If they do, define AS for your tiers and refactor those rules to use them. It's a low-risk change that pays off the next time you scale out. And always confirm current default rules and limits in the Azure docs before you ship. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.